So again, we've got these angles, and this time you've got parallel lines. Okay, you're still going to have your transversal, which is what you had yesterday, but you've got some extra things that's going to come in. I'm going to get you to look for out of the box letters, and you'll see the reason why in Okay, so you've just had a look at the examples, but again, let's have a look at these, the theorems that we're looking about. All right, I said to you a few minutes ago that what we were doing is looking for letters. Well, if you go back to the very first one that you did vertical or opposite angles, vertical or opposite. Okay, depending on what textbook. So don't forget, if you look at what you had, angle A, angle B, and you can make the decision that angle A is equal to whatever the size of angle B is. You've done that one, you've had it a few times. Now it's the first one, they equal each other. Okay, but now let's have a look at your parallel lines. So you've got two parallel lines. The first thing you've got to look for is the fact that they must have either these two arrowheads or tell you that they are parallel. If they don't tell you that they are parallel, you always make the assumption that they're not. And here's your transversal going through. Okay, now there are several things that you can come from this one. For instance, if I'm looking at this as my angle A and this angle as my angle B, I can also say that angle A equals angle B because they are alternate interior, and abbreviate that to that. Okay, so let's take it a little bit further than that. I did say look for letters. Well, if you have a look at this, then what you've actually got is like a letter Z. Okay, if you can find the letter Z, it's so much easier for you. Now let's find the next one. Unfortunately with this one, this is not letters that you can do, but it's the follow-on of what you've just been doing. This is alternate exterior. Okay, and again, you've got to be looking for angles that are on the opposite side of the transversal and they are exterior. Well, if this is angle A and this is angle B, again we can make that angle A is equal to angle B. Simple, easy. Okay, same thing again. Here's your parallel lines, here's your transversal. The next one is this angle here and this angle here. Okay, again you've got to have your parallel lines, so if you don't see that, you've got to make that decision. So again, if this is angle A, this is angle B, okay, these are corresponding. And again, angle A is equal to angle B. If you look again for letters like I'm saying, what you've actually got this time is like an F. So look for like an F or even an E. If you've got three parallel lines, then you're looking for an E. And then finally the last one, and then you'll see the difference. What we're looking at this time is this angle here and this angle here. And again, if one is angle A and this is angle B, this time it's different. Angle A plus angle B equals 180 degrees. Okay, and these are consecutive, or you will often see it as same side. Okay, so why is it important? Well, the importance comes when you are using algebra. Obviously they won't just give you that angle A is 135 and angle B is 45 to make the 180. They will give you something like angle A is 3x plus 2 and angle B is 4x minus 8. You have to add them together to make 180. And again, depending on what they're asking for, if you're asking for the variable, as soon as you find x, you're good to go. If it says find the value of the angle, you've got to find your value, plug it in. But again, it's one of those things, plug it into both of them and then add them together. If they make 180 degrees, then you know that your algebra is correct. The same with the other type where they equal each other. If you plug it into both and both of your angles are 45 degrees, then you know your algebra is okay.